Welcome. Today we're doing our next installment of our axioms. We're doing two today as usual, and they'll go rather simple. Here's the main idea. The main idea is that there are some things that are like water. Let me explain what I mean by that. I keep going back to the analogy with the colors because the colors analogy is so powerful. It tells you everything. Think about this. What if you had yellow and you mixed it in there in your mixing recipe and you mixed it with water? What color do you think you'd get? You wouldn't get pink or red or blue. You'd get more yellow, maybe slightly watered down, but the composition of the color would not change. This does not change the colors. It does nothing. It does nothing. This should be called the do nothing axiom. Water does nothing. And in fact, this turns out to be a beautiful analogy, the perfect analogy to understand the things in algebra. It's amazing how perfect analogy fits, because in algebra, let's go to the next page here. In algebra, we have the additive identity, and it's going to act a lot like water in the world of addition. Let me tell you what it says here. So suppose I have 3 here, the number 3, and I throw it in there into the bucket full of mixing recipes here. The mixing recipes addition, and suppose I throw something in there and it does nothing. Well, we're not going to have water per se. If it was water, you still get 3, but the water element for addition is not so much water. In fact, you can probably guess what it is. It's this number we call 0. When you put 0 in there, it acts like water. 0 does not change 3, and you still get 3. In fact, it doesn't change anybody. You could go, I could put a blank here, and I could put 0 here, and I'll bet you I'd get the same thing. If I have, for example, 5 plus 0, well, you still get 5. You see, I told you. 3 plus 0, well, you still get 3. See, it does nothing. 0 does nothing when you add it to anything. If I have, for example, x, well, I still get x. And so, well, and it goes the other way around too. Let's do it the other way. Suppose I have 0 plus anything, and I will get the same things. So if I have, for example, 11, 0 plus 11 will still give you 11. 0, when you mix it with any other thing, it acts like water. Nothing happens. That, my friends, that's the additive identity. Let's say it in a fancy way. In a fancy way, we could say that a plus 0 is still equal to a, or 0 plus a is still equal to a. It says both of these things. You could also use commutativity to go from this to the other, but it might be a little cleaner just to adopt both versions as the additive identity. What next question you'd want to address would be, well, which numbers does it apply to? It applies to everything, all the numbers, all the symbols, and all the variables, and all the terms that we have in our class. It applies to everything. And of course, we just practiced it a little bit. Practice it some more. You could have, for example, anything. You could have a house plus 0, well, that would still be equal to a house. Money plus 0, well, that would still be equal to money. And on and on and on and on. Alright, you'll have a chance to practice this on the flashcards that I'll post this week. It's easy, right? Let's go on and do the twin version of this. These always come in pairs. There's no exception today. The other version would probably be for multiplication. So talk is cheap. Let's do it. For multiplication, what do you suppose it says? Well, it would say almost identical. I have a mixing recipe here, but the mixing recipe is times. If I throw in there and throw 3 in there, what would I have to throw in there so that I still get the same thing that I start off with, so that nothing's been colored onto 3, nothing's been affected? Well, I could throw a 1 in there, and I could say that 3 times this is still equal to 3. Well, if the number is 1, it works. In fact, it works for anything other than 3. Any of the numbers in our class, most of the numbers in our class, I should say. So, in a fancy way, it says that any number a times 1 will still be equal to a. Or you could flip it the other way. Any 1 times any number is still equal to a. Okay? That's what the multiplicative identity says. By the way, all of these you should be able to look at the axioms from left to right as well as from right to left. You should be very, very comfortable both ways. So the other way around, it would say that A is the same thing as 1 times A, or A is the same thing as A times 1. All these say the same thing. We will call all of them the same thing. We will call them the multiplicative identity axiom. This is the icon. This is the initials for it. Capiche? And of course, just to make it thorough, we will talk about what numbers it applied to, all the real numbers from our class, all the variables and terms that represent real numbers for our class. Okay? And of course, we just practice it a few times. Here's how you'll often see it. You'll often see it with the variables. You'll say x is the same thing as 1 times x. Or sometimes you'll see it with x squared. X squared is the same thing as 1 times x squared. Or sometimes you might see it with fractions. 2/3 is the same thing as 2/3 times 1. Even though we don't know what a fraction is yet, we know it's a number that will be in our class, and that's good enough for us to know that this axiom applies to all the numbers and all the terms and all the variables that represent real numbers from our class. So that's from our class. It'll be okay. 1 times it acts like water. It doesn't do anything to it. Clear? That's what the multiplicative identity says. Multiply by 1, nothing happens. It's a multiplicative identity. Multiplicative water. Okay, it's the multiplicative 0. Add by 0, nothing happens. 0 is the additive water. Okay? Pretty easy. I make it look easy. That's why they pay me. Alright, let's summarize that. Multiplicative identity. 1 times anything is the same thing. 1 times A is A. 1 times A is A. A times 1 is A. Nothing happens when you multiply by 1. A could be any symbol. Additive identity. A plus 0, still A. Nothing happens when you add a 0. Other way around. 0 plus A, nothing happens. You still get A. Works for any A. Additive identity. That's it. See you guys next time.